Hello again, this is Jason Glazer talking about SPC 229 schema data groups again. This time I'm going to focus on pump, heat rejection, and external fluid source. Just as a reminder, for the week after this video is posted, we would encourage discussion by email for any issues found by any member or interested party. After that, we'll have a letter ballot which will also last 1 week. If a minor issue is raised during the discussion, that'll be included in the letter ballot. But if it's necessary, because it's more complicated, we'll refer it back to the schema working group, and it'll be brought up again in a future letter ballot. This video is a continuation of the coverage for the water side HVAC primary equipment. On the last video, we covered chiller capacity validation point, and chiller power validation point. Those are going to be coming up again in a future ballot. In addition, at a prior meeting, we've covered and voted and approved fluid loop and fluid loop design and control. Those are the backbone of the water side HVAC parameters in the schema. Remember that the schema is intended to aid in validating that the transformation between the user's model and the baseline model is done correctly. It's not intended to be a universal model of everything that can appear in a building or be modeled by a simulation program. So let's get started. The diagram on your screen shows the connection of all the different data groups, but we're going to be focusing primarily on the water side, which are near the bottom. So the rule set model instance is the home to many of these data groups. External fluid source, boiler, and also connected is heat rejection and pump, and I know it's hard to tell, but chiller. And then these in turn all point to fluid loop, which points to fluid loop design and control. So that's how the main pieces fit together. And also let's keep in mind that air conditioning systems, the air side of the HVAC system, the cooling system and the heating system also point to the same fluid loop. So let's look at the individual parts of the schema. So as I said, we're starting with looking at how the rule set model instance works. And let me so the ID, reporting name, and notes we've talked about before. These are standard things that appear in almost all data groups to identify the data group and such. And part of rule set model instance is basically a linkage to all sorts of other parts of the model. And in this case, there's a link to fluid loops as well as to all these equipment types that we've been talking about and are going to be talking about today. So the first one we're going to talk about today is the heat rejection data group. And that's located down here. Again, it also has the ID, reporting name, and notes. But then it also references the loop. So this is a linkage to the loop. It's just by reference. So basically the reference ID for the loop will appear there. Following that, there are 3 enumerations: type, fan type, and fluid. We'll get to those in a few minutes. And then there's also an enumeration called fan speed control. Along with that are things that you would typically see as parameters for specifying for any type of cooling tower or an other type of heat rejection system, and that would be range and approach. And then there's also fan power to specify the amount of power the fan itself is consuming. And for the design side, we have 2 parameters having to do with the design wet bulb and water flow rate. And those are the next two parameters. Those are just numeric parameters. And finally, a rated water flow rate. Now that would be at rated conditions. The design ones would be at design conditions, and we specifically suggest using the 0.4% ASHRAE mean coincident wet bulb, but obviously other design conditions might be appropriate. So let's look at those enumerations to explain this a little bit further. So the first enumeration is heat rejection options. And those are basically just the types of heat rejection equipment that are involved here. First is, well, these are really kind of ones that you'd expect. So different types of cooling towers, dry cooler, evaporator condenser, and air-cooled condenser. And then in case we missed one of those, there's also another option. The next enumeration is heat rejection fan options. So that would be a choice, again, of things that you're probably not too surprised about, axial or centrifugal fan. For fluid options, while most cooling towers are simply water, there are other types of heat rejection systems, and for those, refrigerant, ammonia, or perhaps something else could also be a reasonable option for the fluid type. And then finally, the last enumeration is about fan speed control options. And this would be for how the control of the fan is in the cooling tower or other heat rejection system. And for this, we have constant 2-speed and variable speed, as well as other if there is some other type of control system. So that's pretty much it for heat rejection. The next up is looking at external fluid source. It's also down towards the bottom of the PDF file. So external fluid source has the same three starters, ID, reporting name, and notes as most of the other data groups. And it really doesn't have that much more than that. It identifies the loop, that it references a loop, just as heat rejection does and other primary equipment. And then it has a type and an energy source type as two enumerations. Essentially, external fluid source is just a fancy way of saying this is a district system. So this would be very common in a campus situation or perhaps a downtown power generation system where they might have a steam loop that's available to other downtown buildings. So let's take a look at those two enumerations that are involved here. So for external fluid source options, basically there are the three that you'd expect. Chilled water, hot water, and steam as the types of fluid source. And then for the other option was energy source options. This is a little trickier. This implies a knowledge of what the generating equipment uses for producing that chilled water or steam or hot water. So for a campus situation, this is probably pretty well known, but for other situations it might not be. But the options are kind of what you'd expect. Electricity, natural gas, propane, fuel oil. None doesn't really apply here, and then other if it's something else. So that's pretty much it for external fluid source. The last data group that I want to talk about today is pump. So it's kind of the driving force, if you might say, for any kind of central system, primary system. And again, it has ID, reporting name, and notes. Unlike some of the other equipment, a pump can reference not only a loop, but also piping. And a piping system is something we're going to be getting into to talk about more with service water heating. But for now, just remember that this can reference and be used for both fluid loops as well as piping systems for service hot water systems. The first parameter is a specification method for pump. And basically that has two options. We can look at it in a few minutes, but basically it's just simple or detailed. And that applies to these next groups of options. So there's two ways you can specify how a pump is for the power of the pump. One is you just describe the design electric power. And in that case, you've actually set the specification method to simple. The other is that you are looking at the components that make up that. So you'd provide motor nameplate power, the design head, the impeller efficiency, and the motor efficiency. And that is what you use when you set the specification method to detailed. Now, different simulation programs use different approaches here, and that's why we're allowing both of those. Now, a pump will also have a speed control, which we'll talk about in a minute, as well as a design flow, which is a numeric description of how much flow is going through the pump, and also if the flow is auto-sized or not. So it's true if the pump is auto-sized. So let's look at those enumerations next. So the pump specification method options, as I said, are either simple or detailed. And this is just what we talked about earlier. If it's simple, you just provide the electric power. If it's detailed, you're providing some of the pieces that are used to compute what the electric power is of the pump. And then the speed control options are either fixed or variable speed pumping. So I think that's all I wanted to cover today. Thanks again for watching the video. As a reminder, if you have any questions or comments, please just reply to the email that this was sent to everyone so that everyone can see your comments, and hopefully we can resolve them as part of the ballot. In about a week, we're going to be sending out a new ballot to vote on this, so please take a look at that, and I look forward to hearing comments from you. So thank you very much.